Dear students, welcome to the world of chemistry. Chapter 4, Chemical Bonding and Molecular Structure. This is the e-content lesson number 11. Learn chemistry in a simple way. Learn chemistry and enjoy chemistry. Here we can learn about an important topic, molecular orbital theory, MOT, and energy level diagram for molecular orbitals. Let us start. What is molecular orbital theory, MOT, and energy level diagram for molecular orbital? Who proposed molecular orbital theory? Hunt and Millikan. Who proposed molecular orbital theory? Hunt and Millikan. Can you give the salient features of molecular orbital theory? The first salient feature is number of molecular orbital formed is equal to number of atomic orbital combined. That is BMO, that is bonding molecular orbital, formed by addition of atomic orbitals, and AMO, antibonding molecular orbitals, formed by subtraction of orbitals. Second postulate, like atomic orbital, molecular orbital are filled in accordance with the three principles, that is Oersted principle, Pauli's exclusion principle, and Hund's rule. These are the salient features of molecular orbital theory. Then what is BMO? Bonding molecular orbital. Can you define bonding molecular orbital? It is formed by addition of atomic orbitals which has lower energy than the combining orbital. See the slide. It favors the bond formation. That is psi BMO, that is wave function of bonding molecular orbital, is equal to psi A plus psi B. That is bonding molecular orbital formed by addition of orbitals. Then what is AMO? Antibonding molecular orbital. Can you define antibonding molecular orbital AMO? It is formed by subtraction of atomic orbital which has higher energy than the combining orbital. It opposes the bond formation. Only bonding molecular orbital favors the bond formation. Antibonding molecular orbital opposes the bond formation. That is, see the slide, psi AMO, that is wave function of antibonding molecular orbital, is equal to psi A minus psi B. What are the types of molecular orbital? One is sigma molecular orbital and another is pi molecular orbital. What is sigma molecular orbital? You have studied sigma bond and pi bond. Likewise, what is sigma molecular orbital and pi molecular orbital? It is formed by sigma molecular orbital is formed by overlapping of atomic orbitals along internuclear axis. Here the overlapping is maximum and strong bond is formed. See the slide. The oneness orbital added another oneness orbital giving one electron cloud, that is symmetrical around the internuclear axis. That here forms the sigma oneness orbital, that is the molecular orbital. That is oneness atomic orbital added another oneness atomic orbital by bonding molecular orbital, that is addition, we get one electron cloud that is symmetrical around the internuclear axis, that form sigma oneness. Likewise, the oneness orbital is subtracted from another oneness atomic orbital by AMO, by subtraction method, we get two electron cloud, that is pi bond. Then what is how the sigma star oneness is formed? See the slide. That is oneness atomic orbital is subtracted from 1s atomic orbital by antibonding molecular orbital. Through subtraction, we get a sigma star 1s. That is by BMO, that is addition of wave function, that is 1s orbital of 2 atomic orbital, we get a sigma 1s, that is the molecular orbital. By subtraction of 2 atomic orbital, that is AMO, we get a sigma star 1s. That is the antibonding molecular orbital. Then what is pi molecular orbital? How it is formed? It is formed by sideways overlapping of atomic orbital. That is perpendicular to the internuclear axis. Overlapping is weak. This contains 2 electron cloud and not symmetrical around internuclear axis. Then 2s atomic orbital form sigma 2s molecular orbital and sigma star 2s molecular orbital. Also 2pz atomic orbital overlap to form sigma 2pz molecular orbital and sigma star 2pz molecular orbital. Out of the 3 2p orbital, the sigma 2pz atomic orbital intermixed to form the sigma 2pz molecular orbital and sigma star 2pz molecular orbital. That is, one is bonding molecular orbital and another is antibonding molecular orbital. While 2px and 2py atomic orbital intermix to form pi 2px and pi 2py bonding molecular orbital and pi star 2px and pi star 2py antibonding molecular orbital. That is, 2px and 2py atomic orbital sideways overlap to form 2 pi bond. That is, pi 2px is equal to pi 2py, that is the bonding molecular orbital, and pi star 2px is equal to pi star 2py, that is the antibonding molecular orbital. Can you give the energy sequence for boron, carbon and nitrogen? What is the energy sequence up to nitrogen? Can you give? Yes, sigma 1s is the lower energy level. That is, sigma 1s is less than sigma star 1s, that is the antibonding molecular orbital. Less than sigma 2s, less than sigma star 2s, less than pi 2px is equal to pi 2py, less than sigma 2pz, less than pi star 2px is equal to pi star 2py, less than sigma star 2pz. That is 10 orbitals. It contains 20 electrons. Which is the lowest energy level here? Sigma 1s. Which is the highest energy level? Sigma star 2pz. Nitrogen comes in nitrogen, the pi 2px and pi 2py first, then the sigma 2pz. Why? Sigma 2pz molecular orbital has higher energy than pi 2py or pi 2px. Give the reason. The energy sequence up to nitrogen. Sigma molecular orbital, that is 2pz molecular orbital, have higher energy than pi 2px and pi 2py. It is due to orbital mixing effect. Here the energy difference between the 2s orbital and the 2p orbital is very small. They mutually interact and intermix to form known as orbital mixing effect. That is, sigma 2s orbital is lowered at the cost of sigma 2pz orbital, which is further raised. Hence, sigma 2pz orbital has higher energy than pi 2px and pi 2py. Students, can you give the energy sequence for oxygen, fluorine and neon? Yes, sigma 1s is lower than sigma star 1s, which is less than sigma 2s, which is less than sigma star 2s. less than sigma 2p z less than pi 2px equal to pi 2py less than pi star 2px is equal to pi star 2py less than sigma star 2pz orbital. Yes, here the energy difference between the 2s and 2p orbital is quite large, and also we learned that the axial overlapping is stronger than the sideways overlapping. Draw the energy level diagram for oxygen molecule. Can we draw the energy level diagram for oxygen molecule? Give its energy sequence, calculate the bond order for oxygen, and give its magnetic nature. Yes, O2 molecule. How O2 molecule is formed? By combining one oxygen atom with another oxygen atom. What is the atomic number of oxygen? 8. 8 plus 8 is equal to 16 electrons. So, the energy sequence is sigma 1s2 less than sigma star 1s2 less than sigma 2s2 less than sigma star 2s2 less than sigma 2pz2 less than pi 2px2 equal to pi 2py2 less than pi star 2px is equal to pi star 2py. All of pi star 2px and 2py get 1 electron each according to Hund's rule. That is total 16 electrons. The outermost electron contain unpaired electron, that is singly occupied electron. Hence, it is paramagnetic in nature. Can we calculate the bond order? Give the equation of bond order. Bond order is equal to half into Nb minus Na. What is Nb? Number of bonding electron. What is Na? Number of anti-bonding electron. That is bonding electron represent BMO, that is bonding molecular orbital, and Na represent AMO, that is anti-bonding molecular orbital. That is bond order of oxygen is equal to half into number of bonding electron, that is 10, minus number of anti-bonding electron 6. 10 minus 6, that is 4 divided by 2, 2 bond order is 2. That means oxygen contain double bond. That is structure of oxygen contain double bond. Then students, we can do an assignment. Give the energy sequence of N2 molecule, N2 plus, calculate the bond order and magnetic nature. How will you calculate the bond order of N2 molecule? That is nitrogen molecule ion. Nitrogen molecule ion is calculated as N plus N plus. That is nitrogen having no charge, that is atomic number 7, plus N plus, that is 1 electron is removed, that is 6. 7 plus 6 we get 13 electron. That is the energy sequence of N2 molecule ion is sigma 1s2 less than sigma star 1s2 less than sigma 2s2 less than sigma star 2s2, then pi 2px is equal to pi 2py, that is pi 2px2 equal to pi 2py2 less than sigma 2pz1. That is nitrogen molecule ion, that is N2 plus, the valence shell contain unpaired electron, indicate the paramagnetic nature, while nitrogen molecule is diamagnetic in nature, that it contain 2 electron, that is shared electron. What is the bond order of N2 molecule? Bond order is equal to half into Nb minus Na, that is half into bonding electron is 9, antibonding electron is 4, that is 9 minus 4, that is 5 by 2, that is 2.5. Okay students, draw more energy level diagram and learn well. You have clear idea about the molecular orbital theory and energy level diagram for molecular orbital. Learn well. Thank you students. We will meet the next content lesson number 12. Thank you all.